This is Bob Capetta from the University of Illinois at Chicago, and this lesson is partial fractions, repeated linear factors. Here's our example. In the denominator, the factors are x minus 3 and x plus 2. But since x plus 2 is squared, x plus 2 is a repeated factor. So this requires a slightly different strategy. We think about fractions that we could add together to get a common denominator of x minus 3 times x plus 2 squared. We certainly could have a fraction with a denominator of x minus 3. We could certainly have a fraction with a denominator of x plus 2 squared. But we could also have a fraction with a denominator of x plus 2. So here's our model. A over x minus 3 plus b over x plus 2 plus c over x plus 2 squared. And our goal will be to solve for a, b, and c. I'm going to write this vertically first. We want to build common denominators. We want three equivalent fractions with denominators of x minus 3 times x plus 2 squared. So looking at this first one, x minus 3 is already there, so I'm going to need to multiply by x plus 2 squared. X plus 2 squared on the bottom, x plus 2 squared on the top. So my new numerator should be a times x plus 2 squared. Now for this one, b over x plus 2. You'll notice one x plus 2 is already there. We need another x plus 2, and we need an x minus 3 to get an equivalent fraction. And for the last one, notice x plus 2 squared is there. X minus 3 is multiplying on the denominator. Multiply the top by x minus 3. Notice if you reduce these fractions, x plus 2 squareds leaving a over x minus 3. That's what we started with. One of the x plus 2's divides out. One of the x minus 3's divides out. So b over x plus 2 is what's left here. X minus 3 divides out. C over x plus 2 squared is what's left for this third fraction. So now it's time to multiply some things out. We'll multiply these binomials, x plus 2 squared, x squared plus 4x plus 4, x minus 3 times x plus 2, x squared minus 3x plus 2x minus 6. No need to multiply out the x minus 3. So we have these values. Now we're going to distribute the a, ax squared plus 4ax plus 4a, bx squared minus bx minus 6b, cx minus 3c. So what do we have? This fraction equals this fraction plus this fraction plus this fraction. All the denominators are the same, so this numerator equals this numerator plus this numerator plus this numerator. And we're going to need to reshuffle those so that we can identify our coefficients. So all the x squareds need to be put together. That would just be ax squared plus bx squared. All of the x's put together, 4ax minus bx plus cx. All the constants put together, 4a minus 6b minus 3c. So as we do that, it looks like this. Now let's factor out the x squared here, so that'll be a plus b times x squared. Factor out the x here, 4a minus b plus c times x. At this point we will notice the coefficient on the x squared on the left is 3. The coefficient on the x squared on the right is a plus b. So a plus b equals 3. Coefficient of x on the right, 4a minus b plus c. Coefficient for x on the left, 2. So 4a minus b plus c equals 2. Constant on the right, 4a minus 6b minus 3c. Coefficient constant on the left is 17. So 4a minus 6b minus 3c will equal 17. So now I've got to solve this equation, system of equations, 3 equations and 3 unknowns. And that won't be too hard to do. So you'll notice the first equation just has 2 variables, just has a plus b equals 3. So I'm going to do this with substitution, essentially. We're going to solve for one of those variables. So looking at a plus b equals 3, I'm choosing to say a is 3 minus b. Now we're going to plug that 3 minus b into the second and third equation, so that what's left is simply equations in b and c. When we're down to 2 variables, we can solve it. So there is my second equation. 4a minus b plus c is 2. Plugging in the a of 3 minus b, distributing 12 minus 4b minus b plus c is 2. You'll notice negative 4b minus b is negative 5b. So you get 12 minus 5b plus c is 2. And then subtracting 12 from both sides, 2 subtract 12 will be negative 10. So now I have a resulting equation that is just in b and c. Now let's look at the third equation. 4a minus 6b minus 3c is 17. We're going to substitute 3 minus b in for a. So we get 4 times 3 minus b minus 6b minus 3c is 17. Distributing the 4, 12 minus 4b minus 6b minus 3c is 17. Now subtract 4b minus 6b, negative 10b is what we'll get there. So 12 minus 10b minus 3c is 17. Subtracting the 12 here, 17 minus 12 is 5. So our resulting equation is negative 10b minus 3c equals 5. Two equations, b and c, b and c. So use those resulting equations to solve for b and c. Now how do we want to do this? Well, I think the simplest strategy is to go ahead and eliminate one of the variables. So you'll notice this is negative 10b, that's negative 5b. If I can turn negative 5b into positive 10b, the b's will cancel when we add the equations together. So negative 2 times negative 5b is positive 10b. Negative 2 times c is negative 2c. Negative 2 times negative 10 is 20. Adding the equations together, 10b and negative 10b, 0. Negative 2c, negative 3c is negative 5c. 20 and 5 is 25. So if negative 5c is 25, c equals negative 5. Now we're going to plug that c into one of these equations to solve for b. It doesn't matter which one you use. I'm going to choose to use the first one. Negative 5b plus c is negative 10. Let's plug the c equals negative 5 into that equation. Negative 5b plus negative 5 equals negative 10. Let's go ahead and add the 5 to both sides. So negative 10 plus positive 5, adding 5 to both sides gives me negative 5. Negative 5b is negative 5, so b equals 1. So we have b and c. We need to find a. So we're going to plug b and c into one of our original equations and use that to solve for a. Now what were the original equations? We had these before, and we know b and we know c, so certainly the simplest equation to use is the first one. Plugging the b equals 1 into the first equation will enable me to solve for a. So our first equation is a plus b equals 3, b is 1, a plus 1 is 3, and of course a is 2. So we have all of these things. We have a, b, and c. We're going to use them with our original rational function written in the form a over something plus b over something plus c over something. So recall, this is what we started with. So our 3x squared plus 2x plus 17 with the repeated linear factors was something over x minus 3, something over x plus 2, something over x plus 2 squared. And again, notice that these three fractions would have that common denominator. So a is 2, b is 1, c is negative 5. And now we're going to integrate this function, which means we're going to integrate that sum of functions, and those will be relatively easy for us to do. So the integral of the sum is the sum of the integrals, and we know we can pull the constants out in front. 2 comes in front, 1 comes in front, negative 5 comes in front. Now I like to use substitution, so we're going to let u equal x minus 3 and w to equal x plus 2 to go ahead and finish our integration. So if u is x minus 3, the derivative with respect to x of u is the derivative with respect to x of x minus 3. du dx is 1, du equals dx. So this will become 1 over u du. On the other side, w equals x plus 2, notice that'll work for both of these. The derivative with respect to x of w is the derivative with respect to x of x plus 2. So dw dx is 1 and dw equals dx. So this will be 1 over w dw. This will be minus 5, 1 over w squared dw. So again, there's the integral we were left with, and my substitutions are on the side. 1 over u dw, 1 over w dw, 1 over w squared dw. Well, 1 over w squared is w to the minus 2 power. Integral of 1 over u is log absolute u. Integral of 1 over w is log absolute w. We have those. Now this thing, w to the negative 2, kick up the exponent by 1. W to the negative 1 over negative 1. But minus the negative 1, that'll just become plus. And w to the negative 1 is 1 over w. That becomes 5 times 1 over w, or 5 over w. And we finish this problem by substituting for u and w. U is x minus 3. W is x plus 2. And our final answer is negative 2 log absolute x minus 3 plus log x plus 2 plus 5 over x plus 2 plus c. And that concludes this example.